I'm Anil Kumar sharing with you a very interesting question based on rational equations. You need to solve x squared plus 1 over x squared plus 2x plus 2 over x equals to 6, where x is not equal to 0. You can always pause the video, answer the question, and then look into my suggestions. Now let's try to analyze. We have x squared plus 1 over x squared, and here if I take 2 common, I could write this as x squared plus 1 over x squared. Taking 2 common, we could write this as x plus 1 over x, and everything equal to 6. Now to solve this, we can make a substitution. That is, we could replace x plus 1 over x by some other variable. So let y equals to x plus 1 over x. Now what should we do with these x squared and 1 over x squared? Let's find out what is y squared equals to. So y squared will be equal to x plus 1 over x whole square, and when you expand you get x squared plus 2 times ab, that is x times 1 over x plus 1 over x squared, and that really gives you x squared plus 2 plus 1 over x squared. Now here what we see is that we have only x squared plus 1 over x squared. This 2 is missing, right? So what you notice at this stage is that this 2 is missing, but we can always add it, correct? So I'll add 2 to both sides. So then we could write this equation as x squared plus 1 over x squared, and I'm adding this 2. So what I'm doing here is adding 2 to the left side, and also we'll add 2 to the right side. So let me write the other terms, which is 2 times x plus 1 over x is equal to 6 plus 2. So we have added 2 to both the sides. Now that helps to make a substitution that now we can write these 3 terms as y squared, correct? So the equation becomes y squared plus 2 times y equals to 6 plus 2 as 8. You see that? So this is a very familiar equation. It's a quadratic equation which we can easily solve. So let's bring all the terms together. So we have y squared plus 2y minus 8 equals to 0. Product of 8, sum of 2, 8 negative, 4 times 2 can work, right? So we could write this as y plus 4 times y minus 2 equals to 0. And that gives you 2 values. So y could be equal to minus 4 or y equals to 2. So these are the 2 solutions. Now basically we need to find x. We know the y values. So that is to say, writing back into the terms of x plus 1 over x, we have now 2 different equations to solve. One is x plus 1 over x equals to minus 4, and the other one is x plus 1 over x equals to 2. Solving these, we get the value of x, correct? So let's move on, take it on the next page and solve it further. We will now solve these 2 equations, one being x plus 1 over x equals to minus 4, and the other one being x plus 1 over x equals to 2. So let's multiply everything by x. We get x squared plus 1 equals to minus 4x. Bringing them together, we get x squared plus 4x plus 1 equals to 0. Now for this we can use quadratic formula to find the value of x. So x is equal to minus of b, which is minus 4, plus minus square root of b square, which is 16, right? So we get 16 minus 4ac, which is 4 times 1, divided by 2 times a. So this will give us two values, minus 4 plus minus square root of 12 over 2. Now this could be simplified. You can just divide by 2. So 12 is 4 times 3, so 2 square root. So we could write this as minus 2 plus minus, this is 2 square root 3, so plus minus square root 3. Correct? So that is how you could write this. So we get two solutions from the first part. Now let's solve the other half. Multiplying by x, we get x squared plus 1 equals to 2x. Bringing them together, x squared minus 2x plus 1 equals to 0. Now minus 1 times minus 1. So we could write this as x minus 1 whole square equals to 0. So that gives you one solution, which is x is equal to 1. Correct? So we basically now have three different solutions for our equation, minus 2 plus minus 3 and 1. So we can write down our answer as x equal to 1 or minus 2 plus minus square root 3. So that is how you could solve this particular equation. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.